If 10 moles of V2O5 were mixed with 10 moles of calcium according to the following equation, what's the limiting reactant and what is the theoretical yield of calcium oxide? Same as the previous problem, it's a limiting reactant problem, except this time we're dealing with moles of reactant instead of grams, so that makes the problem a lot easier. We don't have to deal with molar masses or conversions along those lines. Let's write our given amounts of our reactants. We have exactly 10.0 moles of each. The approach is exactly the same. To calculate the limiting reactant, we're going to pick one and we're going to calculate if we have enough of the other. So again, we're just going to arbitrarily pick our first reagent, V2O5, and ask if we have enough calcium to react with it all. So our starting point is going to be our 10.0 moles of V2O5 times, now our molar ratio in our chemical equation, 1 mole of V2O5 needs 5 moles of calcium. So I'm going to multiply this by 5 moles of calcium for every 1 mole of V2O5. My moles of V2O5 cancel, and that gives me 50.0 moles of calcium needed if V2O5 is going to be the limiting reactant. But I only have 10. We're told that we only have 10.0 moles of calcium. That's all we have. So we clearly don't have enough. So our V2O5 cannot be the limiting reactant. Therefore, by default, calcium is our limiting reactant. So that being the case, now we can answer part B, what is the theoretical yield of calcium oxide? And that is going to now be based on the fact that calcium is our limiting reactant. And in this problem, they're not specifying if they want the answer in moles or grams. We'll do both. The calculation is a straightforward stoichiometric calculation. Let's first start by writing the equation. And let's draw a line to separate. So we have our V2O5 reacting with 5 moles of calcium. And our products here are going to be 2V and 5CaO. So we got 2V plus 5CaO. Question mark moles, question mark grams of our calcium oxide. So let's go ahead and set this up in the usual way. The nice thing is that we are starting with 10.0 moles, so there's no conversion. We're just right on the molar highway. So we're going to convert that to moles. So let's do that, starting with 10.0 moles of V2O5 times, also we're getting 5 moles of calcium oxide for every 1 mole of V2O5 that reacts, so we're going to multiply this by 5 moles of calcium oxide per every 1 mole of V2O5 that reacts. Moles of V2O5 cancel. And doing the math, we get 50.0 moles of calcium oxide. So that is the amount of calcium oxide formed in terms of moles. Let's do the calculation for grams. How many grams are we going to get? And for that, we're going to need the molar mass of calcium oxide from the periodic table. The molar mass for calcium oxide is going to be 56.08 grams per mole. So this is going to be a simple mole mass conversion. So starting with our 50 moles, 50.0 moles calcium oxide times our molar mass of 56.08 grams calcium oxide per 1 mole calcium oxide. Moles of calcium oxide, of course, cancel. Leaves us with grams, which is going to be 561 grams of calcium oxide. There's our theoretical yield in terms of grams.